Hello, welcome to this session on SQL programming. This is the first lecture. So in today's lecture, we'll talk about what SQL is, what SQL programming is, when do we use it, and we'll also look at some commands that we use in SQL. So before we get into SQL, we need to understand what database is. So database is a special software which can store data. And not only storage, but also accessing data from database has to be easy. So that's why when we say Oracle database or SQL Server database or MySQL database, these are specialized software which has capability to store GBs and TBs of information with itself. So once you save the information, we also need to access that information, right? So SQL, we write SQL, but we call it as SQL, something like this. Okay, so this is a programming language that is used to extract information from databases. Not only extract, but also you can write. So to communicate with databases, we need SQL programming, whether we want to save some data to the database or we want to get some data out of database. Now again, if you look at types of databases, we have many different types of databases. One of the most used type of database is RDBMS. TBMS, single D, not double D. This stands for Relational Database Management System. So when you talk about database like Oracle or MySQL or even SQL Server, okay, IBM has DB2, you have Sybase, Informix, you have Postgres. So almost all the popular database, they are RDBMS systems. So the unique feature, of course, we can talk a lot about RDBMS system, but one of the important key of RDBMS system is that information is generally stored in table format, very much like what we see in Excel. So you have a table, you have row and column, information is stored in table format, one. And second, the tables are connected. So there has to be at least one column which would be common between two tables so that you can form joint operation between one table and another. Now, again, if you want, we can talk a lot about the design aspect of database, how database is designed, how do you decide how many tables to create, how many columns to create. We'll also look at ER diagram. Okay, but if your intention is just to learn SQL, then we don't have to get into those aspects. But my suggestion is that it gives us good idea about what database is. So we should spend maybe an hour or so to discuss about the design aspect. Okay, how do you decide? How do you decide whether this information has to be stored in one single table or it has to go in two tables or three tables? So for example, if you look at employee record, so employee record can have employee ID, employee name, date of birth, address, phone number, email ID, etc. So all this information will be put together in one single table. Now, if you have a department table, okay, so let me write it. So let's say we have an employee table, and employee table can have employee ID, name, manager, email, etc. And then you have second table, which is department. Okay, so let's follow the same structure. Department. A department can have DID, department ID, department name. It can have department head, right? You have VP or so on and so forth. So let's say you have this. Now, Since each of these information is related to each individual, we'll be putting this as one table. The department also, since these are related to one specific department, will have department information here in department table. But obviously, employee will belong to a certain department. Every employee will belong to one department. So how do you link that? How do we say that, okay, employee John belongs to department sales, right? So let's see that in Paint here. So let's say I create this employee table here, and these are the employee specific information. And I've created department table here, which has department specific information. Now you can say that, why don't we combine these two together and form a single table? Of course we can do that. So maybe I can say John, right? And all the information of John. And then I say sales. And I say sales head is Mark. Now I can have second employee, and second employee too belongs to department sales. And again, manager is Mark. Mark is the VP for sales, let's say. So department can have many employees, right? Sales can have 1,000 employees, 500 employees. Product development can have 10,000 employees, right? So what are we doing here? We are writing this information. Of course, we have to write because these belong to one single employee, but we are repeating this for this entire data. Okay, so since all of them belongs to sales, all the information, I have just put 2 columns, but imagine you have 10 different columns. The HR head, um, um, the sponsor of this department, or the head office of this department, email ID of this department. You could have multiple columns that also belongs to the sales or the department table. So all those information, all these 10 columns are getting repeated every time, which is not good. For one, it takes a lot of space. Unnecessary, we are duplicating. Second, it will make reading slow. And third aspect is maintenance. Now let's say if the Mark gets promotion, or Mark's moves to different department, and you have a new person in place of Mark that is heading sales. Now in that case, you will have to change all the 500 or 1000 rows that you have the link to sales, which is not a good practice. So in that case, we would prefer one table, and this we would prefer a different table called department. And this table will, of course, will have sales and all this information related to sales. And this will be just one row, not multiple rows like this. But then how do we link this employee here? So we'll just put one additional column called as department ID. So department ID, we can have 1 sales, Mark, and so on, 2 maybe marketing, 3 maybe product development, so on. And here I'll say, okay, John belongs to department sales, so I'll put DID 1. So now here we are only repeating the key value, department ID, which obviously is not going to change. What changes that we have to make in department will happen in department table, where we are only impacting one row, but automatically all these rows will have the changes because all these are linked to department 1 here, which in turn is linked here. So we have relationship between 2 tables. This is why this type of database is called RDBMS, or Relational Database Management System. SQL is designed to work with RDBMS. That's why I gave you a brief background about RDBMS. SQL programming is designed to work with RDBMS systems. Now, even in RDBMS, we have so many different databases, right? I just spoke about few of them here. Can SQL work with all of these? Answer is yes. Okay, SQL works with all of these databases. It doesn't matter which database you're talking to. SQL command that you're going to learn will work with all of these databases. How? It's because SQL is based on ANSI standard. Okay, so there's a standard called as ANSI standard, and SQL commands are based on that. Okay, so the team that develops SQL command, okay, will follow ANSI standard, and all these RDBMS databases are also supposed to support this SQL commands. That's why when you learn SQL command, you can work with any databases. So when you develop an application, you write this SQL command. It doesn't matter which database you connect to, your SQL program will still work. Now, yes, there are some situations where some commands may not be exactly ported from one database to another, because see, ANSI says what features database should have. So when ANSI says you have to have select, so every database will implement select, but nobody is stopping them. Nobody is stopping the database company to implement new feature. So whatever ANSYS says, they have to do it. So they will do it. Apart from that, to be more competitive, these companies start adding new features. So there are some features in Oracle which may not be supported in SQL Server. There are some features of SQL Server which are not supported in Oracle. But those are out of ANSI standard. Okay, so ANSI cannot say that you should not develop, right? The database can work to develop new features, but the one that ANSI says has to be there. So our aim here is to learn all the commands which are prescribed by ANSI, and we can use it on any databases. So this is a brief intro of SQL. Now if you ask me, what are the capabilities of SQL? Okay, so before again we talk about SQL, we also need to understand some aspects of databases, like what are different database objects. Okay, so let me go to the next slide. Now, if you talk about database objects, the most common is table. This is where data is logically stored. I'm saying logically stored because every software is a combination of files. So physically storage will be one of those files. And physical storage, again, depends from one database to another. Oracle has different set of physical files, which gets created when you install Oracle. SQL Server will have its own set of physical files. So physically, whatever we add is going to get into those files, which we are not bothered. From programming perspective, we need to know logically where the information is saved. So logically, all these databases behave same because they have to implement ANSI standard. So the basic object or the main object of database is called table. This actually stores information. So when we work with SQL commands, we will learn how to connect to a table, get the data from table, put the data into table, edit, update, etc. Second type of object we talk about is called views. Now, views are similar in look and feel to table. So the way table looks, I told you table will have a row and column. Your first row has the column headers, and each row will have information associated with one single value, right? So if I say employee John, so all the information in that particular row will have information for John. And each column has similar type of information. So if I put column header as email ID, all the values in that column will be email ID form, right? So that's table. Now, view is again look and feel it is table. So it has rows and columns, it has column headers, etc. But view is not where data is stored logically. Data is stored on table itself. Views are like table, which is created on top of a table. So I have a table, let's say, finance data, and it has about 20 columns. Now, I don't want people to have access to all the 20 columns. So in that case, I'll create a view with only those columns to which the user can have access to. So I'll create a view on table finance, and I will choose only 5 columns which I want to give access to the other developers. So I'll create a view on table, and I will create such a way that only these 5 columns are selected in the view. So when we create views, we will see how to create, and we'll learn about the commands as well to create view. So when you create a view, okay, such that only 6 or 8 columns are visible, obviously whoever has access to the view can only see maximum of 8 or 10 columns only. So it is a great way, one, to implement security. Okay, even though user has access to the data, but you are not giving access to the real data, but something derived from the table. And the user will never know, okay, because the look and feel of view is exactly same as table. So if you don't tell me, I will not know if that view is really not a table, because I can read, write, update, everything I can perform in that table. And of course, as I said, there are many, and there is one more object which is worth speaking about now, is called indexes. Okay, so index is an object, database object, which is created to make execution faster. Okay, so now first of all, how can execution be faster? Okay, if you look at any book, and the book will have a lot of information, right? But if I want to look at one specific information, how will I be able to go to that location, right? So maybe you have a 400-page book and you need access to one location in the book or one specific information in the book. How will you get to that access? If it is very difficult, you can't go page by page and look for information in every page. So we build indexes. So we build indexes. Okay, so indexes in databases also very similar to the index that you generally see in a book or any of those booklet. It tells you so and so is on so and so topic is on page so and so. If you want to look for ER diagram, visit page number 20. Okay, so now you go to page number 20 itself. Similarly, okay, indexes stores the address of each of the value that we enter, and then it becomes easy for SQL and others to access the data for us. Okay, so again, as I said, once we get into the hands-on coding, we will learn how to create table, we will learn how to create a view and indexes also. But for now, we will look at other features of SQL, and we will definitely do some hands-on today. So if you talk about the operations that is performed by SQL, first thing is called as C, CRUD. C for create, R for read, U for update, and D for delete. Okay, so if you want to create new data, so obviously you can create a new table, you can create a new index, create a new view, and in that, okay, I'm not talking about create object. Create object that we discussed about view and table is a different thing, okay? But here I'm talking about creating data in a table. So you have created the table, now we need to put data into it. right? So we use command called as insert, and we say insert into. Now, one thing you have to be careful about here in in SQL programming is that SQL is case insensitive. Okay, which means it doesn't matter whether you program in capital letters or small letters, okay, or you can use mixed combination of capital, small capital. It doesn't matter to SQL because SQL is totally case insensitive programming language. Okay, so coming back to the operations that are performed by SQL statements, you have insert into. So this is command which we use to add data to a table. So you already have a table created, and if you want to add new content, we use insert command. The next one is read. So we use select. Select command is used to read data from existing table. So you have a table and it has some data, and I want to read those data. Okay, not always you'll be pulling all the information, you'll be pulling a subset of the information, right? So we use um, uh, select to read the data from the database. So C stands for create, R stands for read. Then you have U. U is called update. Okay, this is to update and existing value. Okay, so if you have a database and you have a table and you have a particular information, let's say an employee table, we have um, you have an employee, and now let's say the email ID of the employee has changed, or phone number has changed, or the location address has changed. Okay, so they need to you need to update the information because the information which is in the database is no longer valid. It is old data. So we need to connect and replace that data with new data. Okay, and the last role that we perform is called delete. So totally remove a row from the DB or the table, right? So if there is a data and let's say employee has left the company, so you need to remove the employee information from the table. So you can delete that particular information from the table of active employees. Okay, so when you talk about SQL training, okay, 20% we can keep aside for learning about ER diagram and database objects and things like that. 80% is focused on crude. Even among those 80%, select itself will take a lot of time. Okay, so 80%, 60 to 80% of the work that we do in crude is actually doing read or select. It is possible because the information, as I said, in relational database could be in different tables. So you might have to connect to different table and then read the data. So select can be very simple, but as you start practicing, as you start seeing more information which is getting available or which are linked to the main database or main table, sorry, you will see that the complexity of select query gets more and more. So when we start, or we are going to start anyway today, I'm going to show you how to start with simple select query and then move ahead to more and more advanced queries. Okay, so so this is what I had planned to share as part of theory. Okay, so we can, as I said, right, you can create a data, you can insert is to create, you can read data from the table, you can update or delete, you can create views, you can create functions. Okay, you can even set permissions, privileges to the table or even to the row to the specific users. Okay, so I think now we are ready to practice. As I said, bulk of the time that we will be spending together to learn this, we will be spending on select. Okay, so why don't we start using select today? So maybe next session I'll show you how to install MySQL. Almost all these databases have a personal edition or small edition of database which is free for everyone to use. Obviously, because these companies want you to learn their product and become master in their product, they all provide, like Oracle provides personal edition, SQL Server provide Express edition, right? Anyway, MySQL is free anyway, right? So you can use MySQL itself. So it doesn't matter whether you use your own database or you look at my database, the commands won't change. The commands that are going to do in this training will not change. Okay. So what generally I do is to practice, let's say, reading aspect. So we will be practicing reading and writing or editing or deleting, right? Your writing is more of inserting, right? Insert command. Okay. So for reading, we need database with complex structure with a lot of data so that we can actually be more creative in using our table. So for that, we actually we will use livesql.oracle.com. Livesql.oracle.com is the website where we can practice. Okay, this is where we can practice all our commands. It is owned by Oracle, and Oracle has created a lot of schemas. Schemas are like mini databases which will have its own set of tables and other objects. So we will use this, and the reason I'm going to use this is, as I said, it has a lot of schema, it has a lot of tables, table has a lot of data, and the relationship between them is also complex. So we need a strong database where we can practice and learn difficult commands as well. So that's why I suggest that we will connect. And this is what I'm going to show you now. After some time, we are going there and we will practice there. This requires you to create your username and password. So I already have it, so I'll directly log in, but you can create a login and password there and we can practice there. So that is about reading. Okay. Now for writing or editing or deleting, okay. Now the reason we have to look at different source is that the database which is at livesql.oracle.com is a read-only database because it is open for public. People, if you don't restrict it, then people can add or delete any information, right? And probably they can even, with bad intention, they can even create a lot of problems with the existing data. So that's why Oracle has made it read only. Doesn't matter for select or for a reading practice. But of course, when you want to add new row or you want to edit any column, you can't do that there. So for that, we'll have to install a sample database on our local machine, which we can later use it to perform those activities. And as I said, and in terms of the time that you're going to spend, you'll be going to spend more than 50%, 60% on just single command, which is select. Okay. So for writing, what we'll do, we'll learn later that you can install MySQL database. This is my favorite. Okay. MySQL database you can install, but you can also work with MS Access. You might already have MS Access installed as part of Microsoft Office suite, right? Or you can even install SQL Server Express Edition, or you can use Personal Oracle, which is again a free to use databases. So when you talk about writing or editing, we will first learn how to install a database, and then we will learn how to create a table, how to insert data into table, how to rename something or edit something using um, update. And then you can even remove existing data from the database using delete command. Okay, so I hope I have given enough background about things that we are going to do. Of course, this is not a live session, so I don't have liberty to ask you or repeat something. But obviously, you can ask me any question you have so far, that we have looked at. So without wasting any more time, let's go to livesql.oracle.com and let's practice some commands. So as I said, reading, we need to use what is called as select command. Okay, so we'll see this. So I'm on my Chrome, and here I'll type live SQL. You see, the URL is already saved in my browser, so I don't have to type completely. This is the address, livesql.oracle.com, and you hit enter. Okay, so you get this screen, but again, as I told you, you better create an account. So I'm going to say sign in. Since I already have an account, I don't have to worry too much. But if you are new and using it for the first time, you can click on create account and you can create your own account before using this. Now I'm going to log into LiveSQL. Okay, so now the view that you see is after I log in. So it is personalized view. To open the database, I need to click on this 3 lines that you see here and click on schema. Okay, as I said, schema is like sub databases. Okay, so you have multiple schemas in a database, and schemas will have relevant tables and other objects. You can actually connect from one schema to another, which you cannot do in database. You cannot connect from one database to another database. They are all separate. But schema, yes, you can do that. Okay. So what are the schema here? You click here, you will see academic, analytic views, customer orders, etc. EMP department, all these are schemas. And let's say if you're interested in EMP and department, when you click here, okay, so it has only 2 tables called EMP and department. Okay. So now I'm going to perform some select operations on this. So just remember, it has EMP and it has DEPT. These are the 2 columns. Schema name here, it says Scott. So now I go and click on SQL worksheet. SQL worksheet is the place where you do your database programming, SQL programming. Each of the database, will call this as something else. For example, MySQL calls this as workbench. Similarly, others have other names, but purpose is same, to connect to the database and perform the operation and show you the output immediately. So I'm going to go to SQL worksheet and I'm going to say select star from scott.emp. Do we get anything output? Yes. So you see that? Select, okay, because I want to read the content from the table. So select is command. After select, you tell the columns, which columns information that you want to print. So if I put star, it means I want to read all the columns. So all the columns that are created in the table will be displayed here. I can choose which column I want. I want, let's say, uh, uh, um, Let's say I want EMPNO, which is your EMPNO, which is your employee number. Then I say ename, and let's say I need DPTNO. Okay, so I'm saying select. Earlier I had select star. Star means select all the columns from the database. Now I'm not interested in all the columns. I'm interested in only 3 columns. So I'll say column 1, comma, column 2, comma, column 3. So you have select EMPNO, EMP name, and department number. Okay, now select these 3 columns. From where? That's the next question. So it says, okay, from scott.emp. EMP is the table name, okay, which is in schema name Scott. So if I need to access, I need to say schema name dot table name, and then I'll be able to access to that table. So select. So you have select as a extreme command, extreme left command, and then you have from table, right? So let's assume this way. Your left side is select and right side is from table name here, scott.emp. Now, between your left and the right hand, between select and from, you need to define the columns. You need to define the values that you want to display. Okay, so if I want to display only 2 columns, I will write only 2 columns. I want to display 10 columns, I'll define all the 10 columns. But I need all the columns, and it has to be in same order. Okay, in the order we created the table, you simply say select star. Okay, star means, okay, all the columns. So select star from table name. Okay, so here I have said select EMP number, ename, and department number. So that I want only these 3 columns in the table. So I go and I say run here. So it means, since I selected those 3 columns, I got all these 3 columns. Okay. Now what about the rows? Okay. If you don't define anything, if you don't tell anything, that means that you are looking to get the content of all the rows. So that's why you see content of all the rows here. Okay, all the information which was there, okay, in the main table is being displayed on the screen. So it means that you need to display all the values. But let's say you don't want to display all the rows. You also have some conditions here. So I want to display where let's say EMP number is less than 7,000, right? So I don't want all the rows. I want rows where employee ID is greater than 7,000, or let's say less than 7,000. So what I'll say select EMPNO, EMP name, department from Scott MP, where EMPNO is less than, okay, less than 7,000. That means all the information for these columns from, okay, from Scott EMP, and condition is that EMP number has to be less than 7,000. So now when I click and run it here, okay, no data found. So there's no data which has EMP number less than 7,000. Let me try to make it 3,000. Do we get any information? No. So there's nothing less than 3,000 as well. Let me put 5,000. Oops, here also there is no data. So let me put 900 and see if this works. Yes, this worked. So see here, EMP number 7,300. 7,300 is less than 7,900. Correct? 7,400, 500, 600, 700. Obviously, you will not have something more than or equal to 7,900 because I'm looking for value equal to 9,000 also here. Okay, so you can restrict on the columns, on the information that you are trying to pull. You can restrict on the values that you are pulling using where clause. Okay, so this is the first command that we have learned, which is select emp number ename from scott.emp, where we say that emp has to be less than. So all the values in the given table, which is the table name is scott.emp. So all the values which meets the given criteria will be displayed here. Okay, and this is the basic read command that we do. So now you know how to perform or how to read content from the table, right? And you can have condition. If you do not have condition, you want to display all the rows, then just remove where clause. Just keep it till only from scott.employee emp. So it will display all the values of this table. But if you want to restrict based on emp number, then you'll see where emp no is less than the number. So it will give you values which are less than that employee ID number. Okay. First command that we have learned. Now let's say I want to add one more condition to it. Okay, I want to add one more condition to it, which is let me try here. So I'm just trying to see here. Okay. Okay, so let's write a different query, okay, and then we'll come back and try to combine this query. Okay, so I select same, okay, select emp no ename department no from Scott emp, where, okay, ename, okay, ename is equal to Smith. Okay, so let's see what we get here. Will it work or it won't work? I have made few changes. Okay, first change that you will see here, in fact, only one change you will see here, that is I'm setting ename and I'm comparing the value has to be equal to Smith. Okay, now since Smith is a text, okay, unlike number, okay, so again, I don't know how much programming experience you have. If you have programmed in different languages, the programming languages tries to identify the data, okay, whether it is the numeric data, number data, or text data, or Boolean data where you're using true or false, because the operations that you can perform on these numbers, the operations that you can perform on these value will differ. So for example, if you want to add two values, then the value has to be a number, integer, right? So, okay, you can perform addition on numbers. Now, for example, in this case, I'm performing less than operation. So less than operation can only be performed on number, right? Now here ename, okay, is a string or character. So it contains character. Okay, unlike you see, employee number has numbers, department number has numbers, but ename has text data. So to access or to use text data, you have to use quotation. So I'm going to select this line here, entire line, and I click on run. Okay, so it says Smith invalid identifier. It is invalid identifier. It is because in SQL we use single quote, not double quote. Double quote is not allowed in Oracle text. It has to be single quote. So now when I go and I run this, okay, so no, I ran both. So you should be able to see both the table, right? I ran here, so that means both the commands got executed. So on top, you have the first command, which is um, printing employee number. And then here you have employee number where the ename is Smith. Okay, so this is like printing two different tables together. Now coming back to our example here, let's say I want to print values, okay, which um, okay, which is or where employee number is less than 7,900, and at the same time the name is Smith. So I have two condition here. So when you have two condition, we write or and will be true. We talk about truth table. We can discuss again in detail what truth table is. But for now, understand that truth table means if the both incoming values are positive, only then it is positive. Okay. So I'm saying EMPNO is less than 7,900 and ename equal to Smith. So I'm saying it has to be the person Smith has to have salary more than 7,900, and also the name should be Smith. Now in this case, when I run it, okay, we got this output. You see, there is only one row in the entire table that we're working with. We're working with employee table. So there is only one row where employee ID is less than 7,900, which is 7,369 is the employee number, and name is Smith. Okay, and name is Smith. Okay, I can keep on building any number of arguments. You can use and, or, okay. So if you're using and, then all the data, okay, all the data, okay, or the condition that we are giving has to be true. So the row information that we are going to get will have all these conditions as true. If only all the conditions are true, you get the output. If the conditions are not true, you won't get the output here. Okay. So here, as I said, I can keep on building more and more condition here. And I'll say, and DEPT, right? DEPT NO equal to 10. So now if you see, DEPT NO is 20. So if I run this, this is going to become false. So you won't get any row here. But if I say or, it ran successfully, and okay, you got this data here. Because you're using or means this is also fine, that is also fine. Okay, awesome. So this is how we use where, and you can join the where using and or not. Okay, I hope this was clear. Now you want to display the output. Okay. But you also have some kind of structure in mind. You want to display in a certain order. So, okay, so I'm going to say, I'm going to delete this for now. Okay, so I say select EMP number, ename, etc. Okay, now I'll say order by. Okay, order space by. Okay, commands are also case insensitive. It doesn't matter whether you give all small or all capital, or you can use mix of both capital and small. So if I say order by, and then I put, let's say ename, order by ename. So see, it has displayed the data in order of ename. So A has become first. So Adams is first, then Allen, then Blake, Clark, Ford, James, Johns, so on. The person which had name in uh, as increasing order, you can say, right? So first A, then B, then C, so on. So it is getting printed here. So you can use order by as well. So far we have seen where, and with where we saw and or not. Similarly, here you have order by, where you can choose how the value will be displayed. If you don't mention anything, most probably it will pick the order in which data is saved in the database. Okay, but you can change the order by using order by. Order by column name will actually reorder the data. Okay, so I hope this was also clear. Now, okay, now let's say I want to see what is the maximum value of employee number. Okay, so I'll say select max of EMPNO from Scott.emp. EMP, right? Now I run it. Okay, max. Okay, so max gives us the maximum value of that column, maximum value which is present in that column. So when I say max of EMPNO 9394, this is what I got. Okay, similarly you have max, a min, you have sum, count. Okay, okay, now couple of examples we'll do and we will end the session here. Now in the next example, I want to display, or I want to select the rows where name starts with A. Okay, so again I'll say, I'll take the same example here. Okay, select EMPNO ename department number from Scott EMP, right? And I say where ename like, okay, like is a command, okay, similar to equal to kind of thing, but this is used only for string comparison, not for number comparison. And this also has a or percentage sign that we give when we're giving a value. So I'm saying ename like A, okay, and then I say percentage here. Okay, okay, now you want to see what happens to this. I will select this line and I run it. So see, the whole record has only two records with ename having a value starting with A. Okay, so I said A, and after A, I don't care whatever it is. First, okay, and the commands in SQL are not case sensitive; they are case insensitive, right? As I said, it is not case sensitive; it is insensitive. You can type capital small, but the value that we mention in quotation, single quotation, the string value that we mention is case sensitive. So I used a percentage. That's why it looked for all the values with capital A and anything after that. First character has to be A. First character cannot be anything else other than A. So first has to be A. After that, I don't care what you give, dollar, percentage. Okay, you give whatever you want to. I want to display names which has A anywhere in the name. So I will copy the same command and I'll try to print it here and I'll say percentage. And now when I run it, you should get no data. Okay. Okay. All the names are capital. That's why all these names which are being displayed has a somewhere. I said anything a anything. Anything a anything means I don't care what is before a and what is after a, but in between it has to have a. Then only you display the result. Now see here, all these names, Blake, Clark, Allen, all these have somewhere capital A, right? Now let's say you want to display only with double L. So I'll say LL. That means percentage L percentage. I don't care what comes before L and I don't care what comes after L. In the column E name, I need name with just 2L and I'm done. That's my requirement. Oops, I did not select the entire thing, did I? Okay, now you see Allen and Miller. Allen and Miller are the only two E names values which has double L anywhere in the name. So this is how we use like and read the values which are matching a given pattern. Here pattern is anything LL anything. Okay, it should contain double L somewhere. That's what is the pattern. One last thing that we'll discuss is, let's say if you have to compare multiple values. So here I have said that where order ID is greater than or equal to, right? So we have only one. Now I want to select all the data. Okay, so first what I'll do is I will just select this and run. Okay, just to see the what kind of values we have here. Okay, so now what I'm going to do, I'm going to say select star. Select star means select everything, right? I will see all the columns from where, from Scott, which is the schema name, dot emp, which is the table name that is present in Scott schema. So select star from Scott schema, okay, where e name in. In means, right side, you're giving multiple values. So the left side value, if it is there in the right side value, you get the output. Otherwise, you don't get it. Okay, so let's start from scott.emp where name in, and now you can give multiple values. So name in Clark. Okay, name in Ford. Okay, name in Johns. Okay, and let me add one more from my side, John. Okay, now let's run this command, just this command, and see. Did I not select this? Wait. Oh, I'm sorry. See, it has to be comma, not dot. By mistake, I had given dot here. It has to be comma, right? So now, if you run it, so you see, I said where ename in. So ename in Clark, Johns, and Ford. There is nobody called John in this data set. That's why that row did not get printed. We do have people with employee with ename Clark or Ford or even Johns. So that's why you see this data here. Okay, so we'll stop here for today. Today, what we have seen brief introduction about database. We have learned what is RDBMS. We learned what is SQL programming. Why do we use? Because we need to connect and send information and access information from database. Database has special software which can store large volume of data and help us to even manage data better. Then we started talking about the SQL commands. Okay, we discussed about the way we write the SQL command. Okay, once you um, have the data ready, okay, we can also use SQL commands to insert the data, which we will do later. Okay, not now, maybe first few classes we'll try to understand SQL select only. Okay, once we are comfortable with select, that's when we will create our own MySQL database and we will talk about insert update. Okay, so in select, we learned how to get all the columns or how to get specific columns, how to put conditions on rows. Okay, we started with where clause, then we used where and then we also used order by, where we wanted the output to be ordered by a specific column which exists on left side, right? I cannot say select EMP number from EMP table where or order by something else which is not there, right? So order by should have the column which is present in the left side. So here, if you see, I used ename and ename is present here in this. Okay, so the output will be displayed on a alphabetical order, since ename is a string value, text value, so it is going to print in alphabetical order. Then we also saw like and percentage. So we saw that like is used only on the string data. Okay, and finally we learned in, so it will print values in the given set. Now we also learned functions like max and min, isn't it? So I'll stop here for today. And yeah, we'll meet in the next session. Thank you so much for your time. Bye for now.